Dear students, last class we have discussed about the Heisenberg's uncertainty principle, applications and problem. Today we will discuss some problems related to these topics. You have basic postulates of quantum mechanics, wave function and its characteristics. These theories we have discussed in the last month. I have sent the theory notes and also audio clipping. I make you understood the topics. Today only we discuss focus on the problems related to the topics. The topics probability density, normalized condition, eigenvalues, eigenfunctions, and expectation values, operators, Schrodinger equations. Schrodinger equations have applications. There are three applications: one-dimensional potential well, potential step, potential barrier. Operator each dynamical variable associated with the quantum mechanical operator. Example: energy I h cross del by del t. Already I sent the note last month. You can check the last month note. Momentum similarly minus I h cross del by del x. It is one dimension. If I take three dimension, it is minus I h cross del operator. Del operator. Okay, so last class we have discussed all these topics, theoretical background of all the topics. Today only focus problems. First problem, the wave function psi, which is in different quantum mechanical states, such as psi is equal to 1 by root 3 psi 1, 1 by root 3 psi 2, 1 by root 6 psi 3, plus 1 by root over 24 psi 4 plus 1 by root over 8 psi 5. Question is, what is the probability of the system being in the state psi 5 and what is the total probability? So the solution, as we have discussed, you can check your note. In your note it is written psi is equal to c1 psi 1 plus c2 psi 2 plus c3 psi 3 plus c4 psi 4 plus c5 psi 5. You can check your note. C means coefficient. So if I discuss about the coefficient, then as per the question we have to find out the psi 5 probability. Psi 5 probability 1 by root over 8 is your C5. So 1 by root over 8 is your C5. So solution is P5 means probability of the fifth state, psi 5 state. So it is 1 by root over 8 whole square. So P5 is equal to C5 square. So P5 is equal to C5 square. So C5 is your 1 by root 8. So 1 by root 8 square, that is your 1 by 8. So it is the probability of fifth state, 1 by 8. Then another bit question is total probability. So total probability I will get, you have to add all the probabilities. Probability of each state. Psi 1 state, psi 2 state, psi 3 state, psi 4 state, psi 5 state. So all the probability if you add, then P1 is equal to C1 square, P2 is equal to C2 square, P3 is equal to C3 square, P4 is equal to C4 square, P5 is equal to C5 square. So all the probability if you add, then it becomes total probability. So the coefficients 1 by root 3, it is your C1, it is your C2, it is C3, it is C4 and 1 by root 8 is C5. So take the squares of each coefficient. So take the squares of each coefficient, then you take the LCM. So it is 1 by 3, it is 1 by 3, 1 by 6, 1 by 24, 1 by 8. If you add all these, result is 1. So the total probability is always 1. That means 100%. So the total probability is 1. Then come to next question. Obtain the normalized wave function from the given wave function. So one wave function is given, you have to find out the normalized wave function. Normalized wave function. So to get the normalized wave function, you have to apply the normalization condition. So normalization condition, this is integration minus infinite to plus infinite, minus infinite to plus infinite, psi star psi dx. In some book it is written mod psi square. In some book you can find this psi star psi as mod psi square, magnitude of psi square. So you can write psi star psi or you can write mod psi square, the same meaning. And here psi star is equal to psi. Psi star is equal to psi means why? Because here what is the given value of psi? There is no imaginary part. So though there is no imaginary part, so the complex psi star is equal to the psi, because here absence of any imaginary part. So psi x is equal to n e to the minus x. You see the condition. Condition it is for x greater than 0. It is n e to the minus x, and it is n e to the plus x. It is minus, it is plus for x less than 0. So taking these two condition, we can divide the integration. One is greater than 0, another is less than 0. So for less than 0, I can write minus infinite to 0, one integration, another integration 0 to infinite. So I will take two part, one part minus infinite to 0, another 0 to infinite, because minus infinite to 0 means x less than 0. So this is the condition of x less than 0. So the wave function value is n e to the ax. So as per the case, you have to write psi square. Psi square means what? N square e to the power 2ax. So n square e to the power 2ax dx. So it is the first one. Second part is your x greater than 0. X greater than 0 means what? 0 to infinite. Mod psi square. Mod psi square means what? N square e to the power minus 2x. So n square e to the minus 2x dx equal 1. So this integration divided into two parts. Minus infinity to 0, 0 to infinite, as per the condition as mentioned in the question. Then you have to take the integration. It is n square is constant. It is also n square here constant. So take outside the integration, and the integration e to the 2x dx, here e to the minus 2x dx, and the lower limit 0, upper limit infinity, here lower limit minus infinite, upper limit 0. So by taking the integration, you will get the result n square by 2a from the first integration. From the second integration, you will get minus n square by 2a. So if you add these two terms, the answer will be n square by a. So n square by a is equal to, right side is 1. So n is equal to root a. Then you put the n value. Put the n value in the wave function. So wave function is psi x. So here it is n. So in place of n you write root a. So here also same. In place of n you write root a. And as per the condition, the exponential here e to the minus x, it is e to the plus x, and it is the n value, the constant value, n is equal to root a. So it is called normalized wave function. Now the wave function is called normalized wave function. So as per the question, this is the answer, normalized wave function. Similarly, you collect other problems regarding the probability and the normalization condition. Also you collect some problems regarding the Schrodinger equation. Schrodinger equations, there are two types. One is time dependent Schrodinger equation, time independent Schrodinger equation. Time dependent, time independent, already I sent in the note. So you verify the note about the Schrodinger equation. Two types. Time independent means there is no time term there. Time dependent means there is a time factor, time derivative. So in time dependent there is a time derivative. In time independent there is no time derivative. So you check the note and write the Schrodinger equations. So Schrodinger equation along one dimension, Schrodinger equation along 3 dimension. Again you have to extend this tangential equation as per the dimension is concerned, x axis, y axis, z axis, or in space. Okay, then next we will discuss the application part. So it is your assignment, you have to go through all the theoretical background of each topic. So next I will discuss the application part in my next video. Thank you.